Good morning, you guys. Today is day one of our online learning for the foreseeable future. And I hope things are going well in your world. Things in my world are going fine, other than I feel like I'm getting cabin fever more and more every day. So remember to get outside, try to get some fresh air, and we're going to get through this, okay? My goal is to try to keep our class as close to what it would be if we were face to face as possible. So, for example, you'll notice there's a warm up in front of you, just like there always would be. And so, what I want you to do is get out a piece of paper and a pencil. Try this warm up. Let's see what you remember from before spring break. And I want you to pause the video. And when you are ready to see the answers, go ahead and unpause the video. And I'll remind you guys to do that in different situations. So, pause it at this point in time, take a minute and try these two questions, and unpause it when you're ready to see my answers. All right, so here are the answers I was looking for on this one. The first one you probably wrote was vertex form. That's our most common one. I am doing the best I can to write as legibly as possible. Please bear with me. I'm writing on my tablet right now, so it's not perfect. Okay, so that's vertex form, where H was the left and right movement, but backwards, right? It was opposite of what our intuition tells us. And K is the up and down movement. And then A lets us know how wide or how narrow it's going to be. If A is a positive or a negative, that also lets us know if it's concave up or a happy face, or concave down and a sad face. The next form you probably have is standard form. A is still the same thing, tells us whether it's a happy face or a sad face. But other than that, standard form, we didn't really dive into that a ton, but we did talk about how standard form's kind of tricky to graph. And so we did talk about converting into vertex form, so it's a little bit easier to graph it. And the last one you probably have, now this one, if you don't remember the general form, it's really not that big of a deal. If you just have an example, that's totally fine. But technically the general form for this guy looks like this. And this one's called factored form. Really, if you even put examples of these, like this is an example of one that looks like factored form, that is 100% okay with me. You don't have to remember that P and Q are used in the equation. So for number 2, what information can easily be found from each of the following forms of a quadratic? Easily meaning I'm not converting, I'm not technically doing any math whatsoever. Vertex form is the easy one. You can find the vertex, right? And your vertex is H, comma, K, right? So you can pinpoint, boom, here's where the point is in my vertex. For standard form, you can find the y-intercept very quickly. And the y-intercept is always 0, comma, and then whatever that c value is, that's your y-intercept. And then last but not least, factored form. And that one you can find your x-intercepts. And it's been a long time since we've done this, but your x-intercepts are the opposite of those two factors. So for example, if you had y equals x minus 3 and x plus 1, your two x-intercepts would be 3, comma 0 and negative 1, comma 0. Okay, so hopefully some of that rings a bell from before our extended break. So what we're going to do today is I'm just going to review some of the topics we talked about, because Chapter 9 continues on with quadratics, and we got to make sure we know what we knew back in Chapter 8 as well. So for vertex form, first thing you always want to identify is identify the shifts. Okay, you can also say identify the transformations. So concave up or down, is it wide or narrow? Did it shift left or right, up or down? All that kind of stuff, okay? Identify and plot the vertex. That's always the first point, which is going to be your H, comma, K. Okay, so plot that point first and then go from there. Then use the growth factor for the next point. So remember we talked about A times the 1, 3, 5, 7 rule. Okay, so let's look at this example to see what you remember. If you want to pause at this point in time and try it on your own, that might be a good idea. So our vertex, first shift is with this x minus 3. That means we're going right 3. Remember, it's opposite of what we think it should be doing. The plus 8 at the end tells us we're going up 8. It's a negative 2, so my A value is negative 2, which means it's concave down or a sad face. And we're going to use that 1, 3, 5, 7 to get us some more points once we get started. So if you start at 0, 0, and you go right 3 and up 8, 1, 2, 3, 4, 5, 6, 7, 8, your vertex should be right about there. If your a value is -2, and you multiply and use that 1, 3, 5, 7 rule, then my first point will be down 2 over 1, down 6 over 1, down 10 over 1, right? I hope some of this is kind of ringing a bell. It's been a long time since we've done it, and that's totally okay. So then down 10 over 1. Remember, if you don't have graphing paper, you can probably find graphing applications online, or just do the best you can on a piece of notebook paper, because I know it's not going to be perfect. And don't forget to connect your quadratic, make it look as much like a U as possible. All right, let's review factored form. So factored form was similar, but remember it gives us different pieces of information. So solve for the x-intercepts by setting your factors equal to 0. Then solve for the x-coordinate of the vertex. Again, sorry for my handwriting. I know it's not as nice. And then solve for the y-coordinate of the vertex. Okay, by plugging it in. So here's what I mean by that. Here's our example up here at the top. So my x-intercepts are going to be 5, 0, and -1, 0. Remember the way we did that is an x-intercept is you're plugging in 0 for y. And then it's kind of like you're dividing both sides by -1. Well, 0 divided by -1 is just 0. And then what we did was we set each parenthesis equal to 0. So x minus 5 equals 0, and that's where we got +5. X plus 1 equals 0. That's where we got -1. So first thing I do is I plot those 2 points, 5 and -1. Then I got to solve for the x-coordinate of the vertex by finding the median or the middle. Well, the middle between those 2 points is at -2. This dotted line, if you remember, is called the axis of symmetry. So I would draw the dotted line and say, okay, my vertex is at 2, something. I don't really know what that something is. So to be able to find that, I'm going to plug 2 in. So -1, and then 2 minus 5, 2 plus 1. And if I solve for that, I get -1 times -3, which is 3, 3 times 3, which is 9. So my vertex is at 2, 9. So there's my point. And you can get more points if you want to use the 1, 3, 5, 7 rule. But as long as you have the x-intercepts and the vertex, that's what I'm looking for. You can also tell since the a is -1, notice how it goes down 1 over 1, down 3 over 1, down 5 over 1, and it kind of follows that same pattern. It's kind of the same idea. All right, so we just reviewed graphing. Let's talk about some of the converting that we did before we left for break. So going from vertex form to standard form. My first recommendation on this one, we accidentally want to turn this x minus 2 squared into x squared plus 4, but that's not how that works. So my first recommendation is to actually write it out twice. That's what it means to square something, right? Then I'm going to actually double distribute these 2 parentheses right here. So remember, double distribution is we're going to do x times x, which is x squared, x times -2, which is -2x, -2 times x, which is -2x, -2 times -2 is +4. Okay, so it's almost like you're distributing the x, then distributing the -2. Let's combine some like terms before we keep going. Then the next thing I want to do in PEMDAS, multiplication comes first, so I want to distribute the 3. And my final answer is 3x squared minus 12x plus 7. Okay, same exact thing for factored form to standard form, okay? Double distribute first, so x times x is x squared, x times 2 is 2x, -4 times x is -4x, -4 times 2 is -8. Then distribute the 1/2 into everything. And combine like terms. You could also combine like terms first and then distribute the 1/2, totally fine. It should get you the same exact answer for both of these, okay? Hopefully some of this is ringing a bell. Remember, if I'm going too fast, you can come talk to me during office hours this week. You can also look up examples of things on online, right? There's lots of videos out there, or look at old notes from chapter 8. All right, so standard form to vertex form. So this is when we did completing the square. So example 1, I want to talk about using the pattern blocks first. So using the pattern blocks was what we talked about was, okay, I'm starting with an x squared box, and I'm subtracting 10 x's. So to complete the square, and to keep it a square, I'd have to subtract 5 from each side. So if you ask yourself how many little pieces would be in the top right corner, we would say 25. And we would write this as x minus 5 quantity squared. And ask ourselves, okay, I have negative 4 pieces. So you ask yourself, yes or no, I have exactly 25 pieces. The answer is no. You would say, do I have more than 25 pieces or less than 25 pieces? You would say less than 25. Not only do I not have the 25, I'm in the red 4. So that means I am down 29 pieces. Okay, so that's using the pattern blocks. Some of you guys like that way. Others of you liked the algebra way, where we draw the blanks. So you write the first 2 terms plus a blank, minus 4 plus a blank. And we said, okay, half of negative 10 is negative 5. That's where that piece comes from. And negative 5 squared is 25. But I can't just add 25 into an equation because I feel like it, but I can add 0. So since we added 25 right here, I can subtract 25 right here because it's kind of like I'm adding 0 into the equation. So these first 3 terms turn into that perfect square, and then these 2 guys right here at the end turn into that last number, and you'll notice both of these answers are exactly the same. So it's up to you. Remember, I do recommend you know how to do both, but you'll see that'll come into play later. Example number 2 has a 2 in the front. We've never done one like that before, so here's what that means. This is probably what's going to be coming next, right? After we start reviewing, I'm going to show you how can we do this block idea and also the algebraic idea when we've got more than just one x squared box. All right, so here's what I want you guys to do after you look at the video and kind of refresh your memory. I want you to go to Khan Academy and practice graphing in vertex form and completing the square under the Algebra 1 tab. And I'll show you where to click in a separate video. I'll show you exactly where to go and what I'm looking for that, because we haven't done a ton with Khan Academy this year. But I didn't want to give you another homework assignment because technically you should already know this. So another option is if you don't want to go to Khan Academy and get some practice, you can go back and just look through old homework assignments from chapter 8 that are up on Google Classroom. Just kind of refresh your memory because a lot of this stuff is going to come back in chapter 9, and I want to make sure that we've still got some of that prior knowledge. So again, I hope everything's going okay. Stop by and say hi during office hours if you have questions or if you just want to say hi. I miss you guys, and I hope everything's going well.